and start recording on this. So we modified the DRS settings. We set the automation lamp to manual. We did an aggressive threshold. Leave all of the settings at the default. We clicked OK. We added the ESXi host. We also turned on enhanced vMotion just to see how to do that, and that you can't move a machine in if it's got running machines on it. So that's something you need to, that has to be done during a maintenance window where everything can be powered off. If you need to enable enhanced vMotion. We didn't, because I bought all these servers from a different place than I did last time, and they actually put all the same processors in them, so that was cool. Or prior to this, we had HP servers we bought off of something called GovConnect. Yeah, it's something dealing with the government. So, but they just randomly grabbed out of a bin of random processors and threw them at us. So it was interesting in the past. We did have to use the enhanced vMotion for it to work in groups. But in our case, we have all the same CPUs, but IT did give us 2 new HP servers. Well, the ones they're throwing away, they're new to us. I always keep saying new, but they gave us their old crap, and oh, that's on YouTube, darn it. And so they may not have the same CPUs, but having the enhanced vMotion selected, if we added those to the cluster, it would help being able to migrate if we needed to. Okay, so what did we do with here? Adding, yeah, we added. Task 4, verify Motionworks. Well, we did that in the previous labs. We know it works. We know that works. So the only thing really to do is, you know, if you're messing with your machines, is to double check that while they're powered off, double check that the affinity is blank, and also verify that the CD is set at client device. That would be your best. Task 5 requires every virtual machine to be migrated to a single host. So you don't really need to read the steps on task 5. Migrate every virtual machine, even the people that are absent, migrate them to the lowest numbered host. So how do I know what host they're on? You can click on the cluster. Well, and you can, probably the easiest way is click on the cluster itself, click on VMs, and you can modify. Can you do that now? Just don't guess with HTML5 you can change the columns. Well, that's annoying. They're all powered off, so they're not really attached to anything. Let me go reread that again. Maybe I should read the instructions. So we've got manual. So if I power on, it's going to ask me where to place it. Place them all on ESX1 or the lowest numbered one. You're going to power them all on. And this is the recommendation that talked about in the curriculum about it giving you a recommendation of where to boot it up from. So if I power on all of McGuire's, he's He's not here. Keep picking on him. Keep picking and make sure it's going to swap. Notice it's trying to get me to boot it off of 2. It's trying to load balance me. No, I need them all to boot up off the same host. So always pick the lowest numbered ones, and you got to look at it every time to probably change it.
You're talking about the Unix host, right?
Yeah.
Okay.
Mr. Goodman, is any of my partner? Okay, my partners are here.
Yep.
They're all here.
Yes, they're all here
Okay.
because Haley's going to do Riley's.
Oh, shoot. I didn't know James was here.
Because I don't think Riley's. He's not logged in.
I was just making sure in case I needed to do it.
Right next to me.
Yeah, but he's not here.
Yeah, but
Okay.
Riley uses this computer, but James is
It doesn't matter. You just do everything on your screen.
I am not surprised about that.
He probably jumped on because it was probably up before number 11 was because of power outage. Maybe. So we are coming up here close to break time. Once that you've got all of the machines booted, oh yeah, there we go. There's how you do it now with the new HTML5. You click on your host and you can see that all of them are running. Your lowest numbered host shouldn't have anything running except for that there's some micro virtual machines that run for stuff in the background because you're running in cluster mode. You can ignore the CLSs. Those are part of VMware's Vsphere environment itself. Okay, so let's look at what we need to do next. We need to start a load imbalance, and really the only way to get a true load imbalance, I'm looking here and I've got 48 gigahertz available. That's pretty cool. 57 gigahertz total capacity. And we've got 128 gig of RAM capacity. Just glancing over a few of the things. At the cluster is kind of neat to look at if it were to retrieve data. So as you go on, there's our scores that it talked about. CPU utilization chart. So y'all can find that by clicking on the cluster itself, clicking monitor and looking at under the Vsphere DRS section, the most ones to look at would be CPU utilization, VM, well, memory too, but notice everything should be consumed on one host. We're not at the 50% mark. So there may not be many recommendations even yet. So there's no recommendations right now. It takes a while for recommendations to get on there. So what we're going to do, we're going to go to every virtual machine and go and open up the, whoops, that's not what I wanted to click. You're going to open up a console on them, and you're going to start the CPU busy on each one of them. That will cause a load imbalance, I think. Once you get CPU busy running on your virtual machines, then we can take our 10-minute break. Got now CPU busy on that one.
And the commands per one space CPU busy dot P L, or is it one?
It's Perl CPU busy.pl.
Okay.
Yep. Probably, but anyway, he was missing the CPU busy file. If that's going to run.
I don't have the CPU busy file on my high fill new virtual machine.
I guess you can just ignore that one then.
We may want to rebuild it because we're initially put it together. I just thought we were doing it. So, no, I don't know. Oh, sure. Yeah, it's right. Oh, okay.
Looks of it, looks like my MS-DOS machine is very happy to add here.
What's your DOS machine running at?
Way too much for DOS.
Oh, yeah, that just consumes everything. That's what DOS does. Hey, it works. Cool. We were able to peg it out. Well, we got 2 megahertz free. Let me resume recording again. So, okay. So with all the machines going and running, we max out our processor. And the lab says, so we definitely got a load imbalance. So that was all of task 5. So task 6, verify proper Vsphere DRS cluster functionality. It wants us to, we probably only have to click run now. You don't have to do step 4 here. You just need to click on recommendations and see if there's any recommendations. Well, it says click on your cluster, click the monitor tab, and select the recommendations. Let's see if we can find. There's the recommendations. So I only got 1 recommendation. Maybe I guess we do need to click run DRS now, but we don't need to all click it. So Jared says he's going to click it. Aaron, Andrew's going to click for that group.
I mean, it's my virtual machine, so.
Do I need to click it for my group?
No.
Do we have to hit apply recommendations afterwards, or just run DRS now?
It just said just run. And there, with 24 cores we got, there may not be a lot of recommendations. Seems like there should be a little more than that. Why is it picking on McGuire? Anybody got more than 1 recommendation? Does anybody have no recommendations? So everybody's got 1 recommendation? Interesting. If recommendations appear in the list, do not apply them. Okay. View the information about the Vsphere. Click on the summary tab and expand the Vsphere DRS pane. View the cluster score and the DRS score. Click on information icon next to the DRS score to review how to interpret the VM score. So I hope everybody found the Vsphere DRS under the summary tab, expanded it out. And get everybody a chance to look at that under the summary tab. So continue looking around. So go ahead and look the CPU utilization, go rerun the DRS scheduler and see if there's any new recommendations after you rerun it. It looked like there should be a couple more, but you got two? Okay, that's good. It's kind of open to at least have two recommendations. Now we have a problem. There's only one person can click apply. It's real difficult, but Jared's like, I'm going to do it. I'm going to do it. Okay, so Jared's going to click apply. Let me, it's really easy. You just click apply and you're done, right? So Jared clicked it for his. So if somebody's clicked apply, make sure you look at the monitor recent task at the bottom of the page. And you'll know if somebody clicked apply. You'll see that machines migrated. So we see it migrated a machine. So as I move back and check on the CPU utilization, what happens?
What did- Yeah, I see.
It just popped up as a-
So I see that we've got two machines that have been moved down to ESX2. It appears. I'll look at ESX2, the VMs. So it moved Crane's DOS machine. And then Britain's 04 machine. Didn't really like DOS. I'll put this over somewhere else. So as things stabilize, let's see what it wants us to do now. So as it stabilized and all the migrations has taken effect, it wants us to run DRS again. So go ahead and run DRS again.
Like normal.
So as it has migrated, run its recommendations, re-monitored the system, at least group one has another recommendation. The load balance. It doesn't say apply, but it says double check your summary tab in your monitor. Relook at all of those, relook at your score to see if the score's improved. Did our score improve? So I've got up to 68%, so that's a better score. It doesn't say, but go ahead and apply that extra recommendation if it's got one. And then we'll re-examine this score before we do the task of stopping some of the CPU busies. So yeah, go ahead and apply the recommendations. Once the migration completes, give it about 30 seconds. And then go rerun the DRS and then relook at the score to see if we got an even higher.
It's treating me.
So as we keep watching and keep applying recommendations, this is all manual, of course. If we set it at fully automated, after probably 10 minutes, 20 minutes, it would even these out almost between each other. But our score has bumped up to 79% for this group. Let me read what the rest of this is supposed to want us doing. So yeah, I want you to go ahead and apply the, if you had a third set of recommendations, go ahead and apply the recommendations. This will be our last apply. we'll monitor everything. Then it wants us to, in a little bit, stop CPU busy, but let's let all of the recommendations apply. Let it sit for about 30 seconds after they're migrated. Rerun DRS and check all of our charts and see if we get closer to 100%. What's yours at, Taylon?
Mine?
Yeah,
What's that? Are you talking about the
percentage.
percentage right now is at 96%.
Cool.
We've been doing a bunch of the recommendations and stuff. It hasn't really-
When you're up past 90%, you're probably not going to get much better than that.
Wait, is that supposed to go up?
Yeah, the higher it is, the better.
Oh,
Yeah, I wouldn't do the last recommendation, but so as we're looking through, I see that we're getting a lot better, closer with utilizations. Memory utilization too. It doesn't just take on CPU, it also looks at RAM.
You know, with the black spots one, since it's at 83%.
Nah. No, leave it. So it wants us to clean up the CPU busy. So go ahead and Control C the CPU busy on all of your machines that you've started them on. After they're all stopped, we'll have to let it calm down.
you want us to exit out of the wall? Or
So do a Control C and then and I noticed my my exclamation points against my virtual machines here that I was messing with, they are starting to go away. It takes it a little while to monitor the CPU. It uses an average over several seconds. As I refresh the page, I see my graphs are going back. Memory utilization won't change much. the scores will greatly increase. All we have left is Sean Crane's DOS machine that's throwing a fit. You want to see a pretty chart? Check out the host that you had all the virtual machines running on. We'll go to the monitor and advanced tab and look at the CPU usage. That's pretty. It's every single core just about. Well, yeah, that is every single core up there. Psychedelic, scroll across. Okay. I thought it's pretty. What do you think?
The Spark we've been using.
The other server wasn't so busy. So those are definitely interesting to look at. You see what a system overloaded, at least processor overloaded. Processor overload is probably one of your, it just depends on the industry, what you're doing. But typically the CPU is the one resource that you have more abundance of than any of your other stuff. RAM, the SAN, IO, stuff like that is typically your bottleneck. The last step, somebody needs to disable Vsphere DRS. Jared wants to do that too, I think. So yeah, just right click the cluster, go to settings, and there's a little edit button, and there's a slider, and you turn off DRS. So I can see the cluster's been reconfigured. If everybody wanted just to see it after it's already been reconfigured, you should be able to go to settings and see the same thing. See the edit button, of course, it'll be turned off and you'll just want to cancel it, but that way you can see what your partner did to turn off the DRS cluster. Okay, so we're coming up on another 10-minute break. Okay, so break time's over. It's time for me to put you to sleep. Heck with all those ASMR videos. Works the best. Okay, so introduction to Vsphere high availability. So we need protection at every single level of a data center. We want to reduce planned downtime, prevent unplanned downtime, and recover rapidly from outages. So we've already done some things. This help reduce planned downtime, where we can migrate virtual machines off a blade, do maintenance on the physical blade, bring it back up without ever having virtual machines going down. Prevent unplanned downtime. That would be fault tolerance would be some of the ways to prevent unplanned downtime. Having multiple switches, multiple paths to the NASs, things like that would help prevent unplanned downtime. And then if there was a full outage, high availability is one of the mechanisms for recovering rapidly from an outage, being a physical server or even all the way down to an application failing. Maybe the web app or something, your web server is not responding anymore. High availability has been extended with Vsphere to be able to do that. So there is a difference between fault tolerance and high availability. Fault tolerance basically is to prevent unplanned downtime. High availability is to recover rapidly from outages. So they have two different goals depending on what that you need to do. So yes, high availability is a rapid recovery from an outage. It's cost effective. It's pretty easy to set up. A little more complicated if you need to monitor the actual applications running inside the guest operating system, but it does protect in a lot of different ways. So the main way when they first created high availability was ESXi host failure. The host failed, then the vCenter server would notice that, or other ESXi hosts would notice that the host failed. They would communicate with each other and boot up the virtual machines if there's enough resources to boot the virtual machines up. So that was really great. They have expanded it over their versions that they put out and included VM failure. So if the VMware tools stopped responding and there wasn't something like a normal Windows or something like that shutdown issued, then it will try to reboot that guest OS and get it back up and going. Application failure. You can configure where that certain applications send heartbeats to the VMware tools, which then pass it on up to the ESX host and vCenter server. And if an application, locks up, you can have that the virtual machine restart. And hopefully these applications, that they're talking about, it's not like Firefox running. It's the services that are running in a Windows machine or the daemons in a Linux machine that are running the SMTP server, the Active Directory, the email, the point of sale web application, stuff like that. That's what they're talking about. If a data store gets disconnected from a particular host, maybe because of a network card issue, cable being unplugged, some reason that ESXi host gets disconnected from a data store, it can kill that virtual machine and boot it up on a host that still has connection to it. And then network isolation. If a virtual machine's on a host that somehow gets isolated from the management network, then it helps restart that virtual machine. It's pretty easy. Availability can be turned on just by a little slider, and you can just walk away. And it'll start working. If you need it to protect some of these other components, though, there's a little bit more work that has to be done. A nice graphic scenario here. I guess the host that's in red burnt up. You ever seen a computer burn up? Anybody? Okay, I'm gonna